Most of us walk on it every day without giving it a second thought. It lines our streets, supports our homes, and quietly holds entire cities together. And yet, when we talk about it, we almost always get the name wrong. People say cement sidewalk, cement building, cement driveway. The words sound interchangeable, so we treat them that way. But they aren't interchangeable at all. In fact, one of them isn't even a building material in the way most people imagine. So what's the actual difference between cement and concrete? Why do we confuse them so easily? And why does this small misunderstanding reveal something deeper about how modern life is built? To answer that, we need to slow down and start with what each word really means. Concrete is the solid material you see all around you. It's the hard surface under your feet, the walls of parking garages, the foundations of buildings, the massive structures that shape roads, bridges, and cities. Concrete is what remains after everything else has done its job. Cement, on the other hand, is not a structure. It's an ingredient. Cement is a fine, gray powder that acts as a binder. Its role is not to stand on its own, but to bring other materials together. Without cement, concrete would not exist, but cement by itself is not concrete, in the same way flour is not bread. This is the simple difference most people miss. Cement is one part of a much larger process. To understand why, it helps to look at where cement comes from. Cement begins as limestone and clay, pulled from quarries and crushed into smaller pieces. These raw materials are fed into enormous rotating kilns and heated to extremely high temperatures, hot enough to fundamentally change their chemical structure. What comes out of this process is something called clinker. Clinker forms as hard, pebble-like nodules that are then cooled and ground into an extremely fine powder. A small amount of other materials is added to control how the powder reacts later. That final powder is cement. On its own, cement doesn't look impressive. It has no strength you can feel with your hands, but the moment water is added, something unusual begins to happen. Cement doesn't harden because it dries, it hardens because it reacts. When water touches cement, a chemical process called hydration begins. Tiny particles within the cement react with the water and start forming microscopic crystals. These crystals grow, spread, and interlock with one another, gradually turning a loose powder into a solid mass. This reaction doesn't stop after a few hours. It continues for days, weeks, and even years. That's why concrete can keep gaining strength long after it appears hard. But cement alone still isn't enough. If you mix cement and water, you'll get a hardened material, but it will be brittle and weak. It will crack easily and fail under stress. To become useful, cement needs help. That's where concrete comes in. Concrete is made by combining cement with water, sand, and gravel or crushed stone. Each ingredient has a purpose. The sand fills in gaps. The gravel provides bulk and strength. The cement binds everything together, and the water activates the entire process. Together, these ingredients create concrete, a material that is far stronger than the sum of its parts. A helpful way to think about it is cooking. Cement is like flour. Water alone won't turn flour into a meal, and flour alone won't do much of anything. But when flour is combined with other ingredients and treated correctly, it becomes something entirely different. Concrete is the finished product. So why do we keep calling concrete cement? Part of the reason is that cement disappears once concrete hardens. You never see it again. The binding agent does its job quietly, then vanishes into the structure it helped create. Over time, the name of the ingredient replaces the name of the material. Another reason is habit. Language tends to favor convenience over precision. Saying cement sidewalk usually communicates the idea well enough, so the habit sticks. There's also marketing and labeling. Many products sold in stores blur the distinction. Bags labeled as cement mix often contain sand and gravel already mixed in, which means they're actually closer to concrete than cement. The wording reinforces the confusion. Even professionals slip into it. On job sites, shorthand language spreads quickly. Precision gives way to speed, and the terms blend together. But the difference matters, especially when we consider how these materials behave. Because cement hardens through a chemical reaction, concrete needs time and the right conditions to reach its full strength. If it dries too quickly, the hydration process is interrupted. The result is weaker concrete that may crack or fail sooner than expected. That's why freshly poured concrete is often kept moist and protected. It's not about keeping it wet for appearance, it's about allowing the chemistry inside to finish its work. This slow transformation is one of the reasons concrete has been trusted for thousands of years. Long before modern cement existed, ancient builders were already experimenting with similar materials. The Romans, in particular, developed a form of concrete using volcanic ash. This mixture allowed their structures to survive harsh environments, including constant exposure to seawater. Some Roman concrete structures are still standing today, not because they avoided time, but because the chemical processes within them continued to strengthen the material over centuries. Modern concrete is different, but the principle remains the same.
Not all cement is identical. Different environments require different formulations. Some cement is designed to resist chemical attack in places like coastal regions or sewage systems. Other types are made to harden quickly for emergency repairs or cold weather construction. Concrete itself also comes in many forms. Some concrete is reinforced with steel bars to handle tension and bending forces. Some includes tiny air pockets to improve resistance to freezing and thawing. There are even experimental concretes designed to heal their own cracks over time using chemical or biological processes. Despite all this variation, one rule remains constant: balance matters. The strength of concrete depends heavily on the ratio of its ingredients. Too much water weakens the structure. Too little makes the mixture difficult to work with. Small changes in proportion can make a big difference in durability and performance. Once poured, concrete doesn't reach its final strength immediately. It continues to harden and improve for years. Massive structures like dams behave this way on a monumental scale. Some are still technically curing decades after construction. Cement's role isn't limited to concrete either. It's used in mortar, which holds bricks together, in grout, which fills the spaces between tiles, in stucco, which coats and protects exterior walls. In each case, cement acts as the binder, the invisible force that turns loose materials into a single surface. But you would never build a skyscraper out of cement alone. Concrete is the material that defines modern infrastructure. Roads, bridges, sidewalks, tunnels, foundations, seawalls, and entire cities depend on it. Its reliability, versatility, and relative affordability have made it one of the most widely used materials on Earth. That widespread use comes with consequences. Producing cement requires enormous amounts of energy, and the chemical process releases significant amounts of carbon dioxide. As a result, cement production contributes meaningfully to global emissions. This has pushed researchers to look for alternatives and improvements. Some new concretes are designed to absorb carbon dioxide as they harden. Others replace portions of cement with industrial byproducts, reducing environmental impact without sacrificing strength. And through all of this innovation, the original distinction remains. Cement is the quiet enabler. Concrete is the visible result. One is a powder waiting to react. The other is the hardened world we move through every day. So, the next time you hear someone say cement sidewalk, you'll know what they mean and what they're actually talking about. More importantly, you'll understand that some of the most important things in our lives are the ones we rarely notice. They sit beneath our feet, silently doing their job, holding everything together without asking for attention. Thank you for watching. If you have a question you'd like us to explore next, feel free to leave it in the comments. We enjoy uncovering the quiet stories hidden in everyday things. And if you'd like more calm explanations like this, consider liking the video and subscribing. We'll see you in the next one.